You've probably watched a Khan Academy-style video before. A friendly voice explains a concept, while diagrams and equations appear on a digital whiteboard perfectly in sync with the narration. It's a powerful way to learn, but creating even a short 5-minute lesson like this is incredibly labor-intensive, often taking a human instructor hours of painstaking work to get the timing just right. As of July 2025, a new research paper proposes a solution. It's a system called Whiteboard Gym, and it's designed to automate the entire process. The idea is simple. You give an AI a lesson transcript and a blank canvas, and it generates a complete, time-aligned whiteboard video. The core challenge here is replacing the human intuition of a teacher. The AI needs to figure out not just what to draw, but precisely when to draw it, so that every visual element appears at the exact moment it's mentioned in the narration. To solve this, the researchers framed the problem as a sequential game for an AI. At any given moment, the AI agent looks at two things: the current drawing on the canvas and its current place in the lesson transcript. Based on this, it has to choose from a simple set of actions: draw a stroke, write some text, add an image, erase something, or simply wait. But how does the AI know if it's making good choices? This is where the most critical part of the system comes in: the reward. The AI is graded on a combination of 4 key pedagogical criteria. First, visual clarity. Are the diagrams easy to read and understand? Second, pacing. Is the drawing happening at a good speed, keeping up with the speech without feeling rushed? Third, learner engagement. Is the amount of visual activity just right, enough to keep the viewer interested, but not so much that it becomes distracting? And finally, semantic alignment. Does the image on screen actually match the concept being discussed in the narration? To build an AI that can master this game, the researchers used a multi-stage training pipeline. First, they needed to give the AI a basic sense of what a good video looks like. They did this through a process called behavior cloning. They showed the AI 50 short video demonstrations made by humans, only about 10 minutes of total footage. The AI's initial goal was just to imitate these examples. This gave it a solid foundation, a kind of warm-up for the real training. But imitation alone isn't enough to create truly great content that can adapt to any new script. For that, the AI needs to learn by doing and get feedback on its own original creations. This is reinforcement learning. The problem is, you can't have a human expert sit and grade the thousands of video clips the AI generates during training. It would be impossibly slow and expensive. So, the researchers created an automated AI judge. They started with GPT-4o, a very powerful language and vision model, and had it score generated videos on those 4 criteria: clarity, pacing, engagement, and alignment. But calling a model like GPT-4o for every single training step is still too slow. So they performed a clever step called distillation. They used the scores from GPT-4o to train a much smaller, faster, and more specialized AI judge, a fusion of a vision model and a text model. This distilled judge could provide high-quality feedback almost instantly, making the reinforcement learning process practical. With this fast-acting judge in place, the researchers trained their whiteboard agent using 2 different high-level strategies. The first is a popular and well-established algorithm called proximal policy optimization, or PPO. PPO uses an internal component called a critic to estimate how good its moves are. The second strategy, and the paper's main contribution, is a new algorithm they call Group Relative Policy Optimization, or GRPO. Instead of relying on an internal critic, GRPO is more like a continuous competition. For any given moment in the script, it has the AI generate a small group of different drawing sequences.
It then scores each attempt not in isolation, but relative to the average score of the group. This group-based comparison turned out to be a more stable and effective way to guide the AI's learning. When the results came in, the numbers showed a clear winner. the GPRO agent achieved the highest overall reward score. But the most telling result came from a final qualitative test. The researchers took the videos generated by the different AIs and showed them to Gemini, Google's native video understanding model, for a series of 400 blind head-to-head comparisons. The results were staggering. Gemini preferred the videos made by the new GPRO agent 80% of the time. The standard PPO agent won only 19% of the time. The agent that only learned by imitation won 0%. A closer look at the videos revealed why. The PPO-generated videos, while decent, had a slight but noticeable flaws. They often had a slight lag, drawing a key diagram a second or two after it was mentioned in the narration. They also tended to have what the researchers called erase spikes. Frequent, abrupt flashes on the screen as the AI erased and drew parts of the canvas. In contrast, the videos made by the GPRO agent felt smoother and more synchronous. The key visuals appeared right on time, and the canvas remained visually stable, creating a much more professional and less distracting viewing experience. Ultimately, what this research demonstrates is that with only 10 minutes of human demonstration data, an AI can be trained to produce high-quality, pedagogically sound educational videos that an expert system judges as superior 80% of the time. The authors are clear that this isn't about replacing human educators. Instead, they see it as a powerful tool to amplify their abilities, freeing them from the tedious work of video production so they can focus on what truly matters, the teaching itself. This work lays a foundation for a future where high-quality, on-demand educational content can be created at scale for any subject and potentially in any language.